Good afternoon, good morning to everybody, wherever you are. My name is Robert Lesar, and I will show you, or I will present you this webinar about Cisco SD-Access. Before we start, this session will be recorded. When you enter to the session, you are muted. So if you have any question related to this session or the topic, please paste the question in the Q&A section of this webinar. Okay, I'm coming from a company NIL. Company was founded back in this year, so 1989, and company is Cisco Gold certified partner from 1995. We have a headquarter in Slovenia, but we have offices and representatives in other parts of Europe, as well in Africa, Middle East, North America. So we specialize in advanced data center, networking, cloud, cybersecurity, collaboration technologies. NIL is part of Concha Group from last year. So at this point, I welcome to all Concha customers. Thank you for coming to this webinar. I hope you will enjoy it. So in relation to this SD-Access, NIL is offering consulting services as well as other solutions related to skill enablement. So we can prepare training so for your team or customers or partners. We also are carrying some mentored installed. If you are interested in that, let us know. So on this webinar, this is a short webinar, we will I will present you four key things. First is some motivation for the SD-Access. So why would we go there? What are current issues we may have in the network, and what kind of solutions SD-Access can bring up. So we will talk about motivation, some key concepts where I will really go to high-level key concepts so that you understand what technologies are included in the SD-Access. And at the end, I will, well, not at the end, but next thing, I will demonstrate you in a very short demo how SD-Access can be used in the practice to simply enable one policy. And the last topic here is about roadmap, licensing, and resources, so where you can get more information about SD-Access. So related to the motivation, we will look first in some traditional network challenges that we may have. So I divided these challenges in some categories, like we have network deployment challenges. So how you are deploying your network. We already talked about some automation last time on the webinar about DNA Center. So SD-Access is also heavily using this product. So that's why I will be mentioning DNA Center a lot through this webinar. So with the deployment, we have some challenges with network security as well, because we need to take care of segmentation and keep this segmentation from the end to the end. Then wired and wireless networks are normally running with the multiple policies, with the different addressing schemes, like DHCP configuration is complex, and we need to take care of security policies when you are in the wired or where you are in a wireless network. So with such solution as SD-Access is, we are bringing this together on the same platform. So when you create a policy, you know that this policy will be held, doesn't matter whether a client is wired or wireless. And as well, there are some operational challenges where when we are looking for different areas like LAN, WAN, and data center, different tools are used to manage these parts of the network. So SD-Access, as you know, is related to the LAN environment. So that's why, let me show you a topology of a typical LAN environment where you have access devices or access switches at the bottom, where all your servers and end devices are connected to. And from the access to the aggregation layer switches, normally we have a level 2 connectivity. So we need to deal all about this VLANs, about trunking, about spanning tree protocols, and so on, and as well some security, let's say, policies are done with different layer 2 solutions. When we get from the aggregation above, we need to talk about layer 3 topologies, where we are entering different layer 3 policies in that. And this is today a burden, because even if we talk about security or quality of service to the network, we need to have different applications or different features to address this in the level 2 or in the level 3 part of the network. And then on the top, as you can see, there are other parts of the network that we will not address today, but they are also very important in this automation part that we want to address with new solutions. So data center, one part, and other services part. Okay, all these topology challenges are shown here. So when we have level 2, level 3 parts of the network, so we need to make sure that STP, so spanning tree protocol, is tuned correctly. First hop redundancy protocols are done correctly. Then we go, of course, spanning tree has its own complexity, limitations. Then we go to the QoS policies that needs to be different for the level 2 as well for the level 3, as well on the security part, where we normally need to address, let's say, some access lease on the MAC address level. And then when we move to the level 3 part of the network, we have this in the IP access list. So these are a couple of topology challenges, and as you know, you may already seen this picture before, at least this part on the left, where Cisco is showing in such a, let's say, simple diagram what is their thinking on how to manage or how to operate networks in today's environment. So we have some intent, business intent, where we say what needs to be done, goes to the network devices. Network devices are configured. In our case, these are switches, routers, wireless LAN controllers. And then these devices are providing some content back to the DNA Center, where this content is shown and analyzed through the analytics part of the DNA Center. Now, from this part, as you can see, you can address LAN portion of the network. So this, we will have a solution called SD-Access. We can address one portion of the network for this solution, which is not, let's say, covered in this webinar, is SD-WAN. And when we talk about data center has its own, let's say, controllers that is addressing data center implementation. Okay, so now you know where to position SD-Access. So this is a LAN part of the network. And now I will show you what SD-Access is bringing into the table. So what are the benefits of the SD-Access? So first, when our SD-Access network works, as I explained you before, this is in the LAN part of the network. We need to make sure that devices are configured automatically. Normally, it is done through the DNA Center. So we have this automation part done. Then any kind of policies that may arise here. So, for example, IoT devices should not communicate it with enterprise, with let's say employee devices, or servers should not directly communicate with IoT devices and so on. So we have some kind of separation or some kind of policies between devices, and these policies are enabled through the DNA Center, but they are actually configured on the ICE. So this is identity-based policy and segmentation, which is done independent from the IP addresses and VLANs. So we will not talk anymore about VLANs and trunking, but rather in what VN device is sitting, or in what scalable group device is sitting. And as I showed you before, all these, let's say, performance factors, or all these performance parameters are then collected by the DNA Center, by the assurance part, where we can see how clients are performing or how applications are performing in our network. Okay, this is just for your reference. So SD-Access provides us end-to-end segmentation, at least when we talk about the LAN part. But you will learn later that also end-to-end segmentation is related to the other parts of the network. So to the WAN part or to the data center part. Improved workforce experience, where all these services are automated. Operational efficiencies, because everything is now operated through one controller, which is a DNA Center. So DNA Center is a key component we are using in this solution. And we are basically doing all this stuff through the DNA Center. So no need to go to the devices and perform some CLI magic. Everything is done through this GUI-based controller. And at the end, of course, these business insights that are shown in the DNA Center. Now, when we look into this motivation, let's look into what is SD-Access. Of course, there are many components, but if you want to understand what are those main components, basically, this sentence is true. And so basically, SD-Access is a campus fabric, which has a couple of switches or routers, plus controller. In our case, controller is Cisco DNA Center. So when we look into the campus fabric, we are basically talking about a combination of control devices or control switches, edge switches, control switches, or control plane nodes, and border nodes. So these are key components. But as you can see on this topology, we can have other devices that are also part of the fabric, but they don't understand any of the protocols that I will talk about them. So no other protocol needs to be understood by those. They just need to provide this connectivity between those devices. Now, we talk about a fabric. Basically, it means in the fabric, every device that connects to those switches below can communicate between each other. So this is somehow definition of the fabric. But with the SD-Access and with the policies, we can have many manipulation of this policy, saying who is able to talk to whom, or what protocol is allowed from, let's say, department A to the department B. Now, I will show you other key components, but for now you need to understand that campus fabric is portion of our network where we normally had those switches with a level 2 links between, with a trunk between them and so on. But now we have switches with the level 3 links between them and routing protocol running here to support our underlay. Because underlay will then provide functionality of the overlay that we want to build on top of this. And now let's move further. Let me explain you the other stuff. So as you see, I'm often talk about underlay and overlay. I'm sure you already heard about these, let's say, keywords or words. And on the table, on the screen, you can basically see a couple of technologies that you may learn from before that are actually examples of the overlay. For example, GRE is one of such. So you need to have some connectivity, but then you can create a GRE tunnel, and this brings you an overlay to the standard underlay topology. Same is with the MPLS, DMVPN, which is just another saying of dynamic GRE tunnels and so on. And so there are many examples of these overlay topologies that we want to build here. Yeah. But for the overlay technology to work, we need to have some kind of encapsulation. Now, this encapsulation, as you will see later, is basically a VXLAN encapsulation that we are talking about. So if those underlay devices below are providing connectivity, we have these level 3 links between those devices. We have IGP running between devices, so to provide full connectivity. But now, if I want, let's say, A to communicate with B, I need to have some overlay encapsulation, and for this encapsulation, I'm using VXLAN. You will learn later that for a VXLAN, so if this is my original packet, and this is my VXLAN encapsulation, plus outside IP header, for this VXLAN encapsulation to work, we have two values that I will describe a little bit later. We say they are VN as a virtual network value, and SG tag, scalable group tag, or security group tag, or source group tag, whatever you want to say. Well, it is actually the same thing, but it may be described differently from department to department. So we will talk about scalable group tags here. So this is important for our VXLAN encapsulation. To put everything together, as you can see, our fabric, I already present you before fabric edge nodes. These are responsible for classification of the traffic. So when a device connects to the fabric or to the SD-Access, I need to know how to classify this user. So in what VN or what SG tag this user should use. So classification is normally done here on those edge devices. Control node device is basically a Lisp server that is providing a mapping between those endpoint IP addresses, or we call them end IDs, because it is not always IP address. It can be a MAC address as well as RLOC address, which is a loopback address of those edge devices. And so I need to know, in order to reach, let's say, B, I need to know into what rlock, this B should be encapsulated. And remember from before, outside IP address needs to have some kind of source and destination IP address with it. And so that's why control plane node is basically a Lisp server that is providing this mapping. Then the other thing is border nodes. As you can see, we have two of those here. These are responsible for connecting my SD-Access to other SD-Access environments or sites, or to other non-SD-Access sites. So with other words, this means that border node is responsible for redistribution of the BGP routing into the Lisp routing inside. Or if you have other, let's say, OSPF routing outside to the Lisp routing inside. So this is very high-level definition of the border router. Okay, with this in place, I already explained you before, we need a controller where we combine all this stuff together, where we configure everything. And this controller, which is a DNA Center, communicates with the ICE, because really ICE, Identity Service Engine from Cisco, is a central point of all the policies all the PX grid policies that exist in this network. And every time a new user connects to the edge device, this edge device or switch will contact to the ICE. So the ICE tells him into what VN or into what SG tag this user belongs to. So these are main components. Of course, when we want to enable SD-Access for the wireless, we add a wireless controller into, because wireless and wireless LAN controller then communicates to the access points here and make them part of this fabric domain. So these are main components. Remember, edge nodes, control plane nodes, border nodes. So these are the main. And those devices in the middle, as I told you before, they just need to make sure that they understand our routing. So running ISIS or OSPF internally. And they need support NTU high enough to not have any kind of fragmentation inside our network. So this VXLAN brings 50 additional bytes to the encapsulation. So have this in mind that these devices here internally, they need to support jumbo frames. So everything what is above 1500 bytes. Okay, I already explained this before. If this is now my fabric environment where I'm running SD-Access, I do some kind of segmentation of this. And this segmentation is so-called macro and micro segmentation. And VN, or a virtual network, provides me a macro segmentation, meaning, okay, now I'm putting some devices in the VN1, which is for the campus, VN2, which is for the IoT devices, and VN3 for the guests. By definition, these should not communicate between each other inside the fabric. So the only way, let's say, a campus device communicates to the IoT device is by going out from the fabric and then being somehow manipulated or policed outside the network, whether it is with the access list, whether it is with the firewalls, and only then such packet can be rerouted back to the IoT VM. So no communication can happen inside the fabric itself. And so that's why we call this virtual networks. And we normally put, let's say, users in a completely different VM if we really don't want them to communicate with any other users internally. For example, IoT devices is one of the examples of those, because we don't want those devices that are, let's say, communicating with building systems like heating, ventilation, lighting system. We don't want this to be anyhow interrupted with the let's say campus environment, or even not with a guest environment. And so we want to keep even guests in a different VM. So if we take some analogy from before, we will have a completely different VLAN for the guests. Okay. Micro-segmentation is done with the scalable groups. So to put this once again together, scalable group is basically same as a security group on the ICE. So if you look into the ICE, which is coming from the security business unit, they are saying security group tag. But when you look to the DNA Center, when they want to control different parts of the network, not only security from the security portfolio, but also networking and other portfolio, they are calling this scalable group tag. But in reality, none of this is correct, because if you look to the Lisp definition, SGT is basically meant to be used for source group tag, because then there is also a thing used as a destination group tag. But let's not go into such details. Let's just say, okay, now we are using these scalable groups for micro segmentation. What does it mean? If I have inside my VN a couple of scalable groups, let's say A, B, and C, I have in my PX grid on the ICE, I have this, let's say, table that says if, let's say, if a source is A and if a destination is A, they can communicate between each other. If a source is A and destination B, they communicate. And so this is a scalable group tag on a micro segmentation level, where you can have communication with everybody inside the same VM. And then, as I will show you later in my demonstration, you can make some policies saying, okay, now B and C should not communicate, or B and C should have some restriction in communication. And as you will see from my demonstration, it is very easy to achieve. So you get to this table, you click to the portion of the table you want to manipulate, and you add a policy on it. So it will not matter whether this user is connected via wired or a wireless, whether it is connected in a building A or a building B, or in any other floor via a wireless. This user will always have the same policy attached to him, because this policy is described with a scalable group tags. So as I explained you before, SD-Access brings us completely IP agnostic or VLAN agnostic security policies by implementing these two features. So VN and scalable group tags. So it doesn't matter what kind of IP address you have, it just matters what VN and scalable group tag you are holding. So to bring this together, so all these components together, what we learned is that we have a Lisp. This is a locator ID separation protocol, which is used as a control protocol. So this protocol will tell to the endpoints or end devices how to reach, let's say, another user in the network. And so it will make a mapping between end IDs and RLOC addresses. Then we have VXLAN, which is used for the data plane, meaning how traffic will pass through the network. So what is our overlay? And this is encapsulation we are using. In this encapsulation, VN and SGT are used. And then as the last part is this Cisco TrustSec environment, where all these policies are done on the ICE. Of course, not directly configuring ICE, but basically configuring DNA Center, where DNA Center communicates with the ICE. And then on the ICE, you have all the policies for your environment available. So now when a new user comes to the switch, this switch will ask to the ICE into what group this user belongs. ICE will provide a AAA service, so we'll provide authentication. We'll provide authorization by saying, okay, this user should belong to this VN, to this SG tag. And then my switch is able to classify this traffic. Then when a traffic is classified, the switch will ask to the control plane, please tell me, my user wants to communicate with this user, let's say Y here, and my user is X. Please let me know where I can reach the user Y. And control plane, so Lisp will provide information to him, telling him Y is reachable over this switch, let's say B on this side. And this is the way how VXLAN is able to now cross across the network. So we have propagation of such packets. And then on the egress switch, the policy will be enforced. So now this egress switch will check whether this user X belonging to the, let's say, specific group is able to communicate with the user Y. And the enforcement will be done on this point. So once again, classification on the ingress, then propagation of the traffic through the VXLAN, and then the last or egress device will enforce specific policy, whatever we configured before. So policy enforcement is done in there. You may say, well, it is a waste of the bandwidth. Yeah, it may be true, but the reason for this is that not all the switches that we have here will have the full pxgrid table downloaded to them. So the switch will only download the part of the table that belongs only to those users that connected to this switch. I hope this is not too complicated, but it is how it works. And so we have these three components: Lisp as the control plane, VXLAN, and policy plane is done through the Cisco TrustSec. And yeah, I think we already saw this before, so let's just move further. So we have underlay, where we need to provide connectivity, and then DNA Center as a controller will basically configure this and will tell the policy, and we will be able to connect like desirable user to the desirable user in the fabric. Short demo I will present here. So let me show you quickly how, when you have your DNA Center set, when you have your SD-Access environment all set, and now you have some kind of macro segmentation done, and you want to make sure that you will now manipulate micro segmentation. So I will walk you through how group-based access control can be done, and then how to create a policy and verify this. So very short demo I will show you here. So inside the DNA Center, you go to the policy. We need to make sure that migration with the ICE is done. So ICE and DNA Center are communicating. So all SG tags found on the ICE can be now found on the DNA Center. Then we go to the group-based access control policies, and you will find such table that is shown here. you select, okay, I want to manipulate a policy where employee communicates with a contractor. And I want to make this in both directions. I select this box here, click to the box, create policy window will pop up. And now I'm able to select two contracts that are by default already there, but I can create my own contracts. So contract is basically level 4 policy that tells me what protocol is allowed. But let's say that now my contract will simply be deny IP. So I will just select that one, save it, and that's it. So from now on, when employee wants to communicate with a contractor, he's not able to do that because we created this policy. Of course, in this process, as you saw, it is very short process. Just select the box, select a policy, bam, you are done. You need to click to this deploy button so that policy will be deployed to the switches themselves. Okay, and the last topic is on roadmaps, licensing and resources. This picture shows a couple of previous versions of the SD-Access, and as you can see, this is more for your reference than for me to explain all this stuff. You see that Cisco is really building this product and this service. So with every new SD-Access version, you have more and more support for the switches and other devices. I'm pretty much sure you're all very familiar with the new licensing. So before we had this 3-tier packaging with a LAN-based, IP-based IP services, but now we basically have 2-tier licensing where we have essential licensing and advantage licensing. And if you want your devices, router switches, to be controlled by the DNA Center, then you need to add this DNA Essential and DNA Advantage license. Network licenses are permanent. They are coming with the box itself, but those DNA licenses are subscription-based, so 3, 5, 7 years subscription to the license. Basically, if you want to run SD-Access on your devices, you will need actually full license. You will need this network advantage and DNA advantage license. If you want to learn more about what device is compatible with SD-Access solution, there are 2 links. I will paste these 2 links later in the Q&A session so that you don't need to remember this. But basically, the first one is compatibility information, where you will find some compatibility metrics tool. You can even download this Excel spreadsheet where you will find the devices, what version is recommended for the devices to support SD-Access. Or you can play with this compatibility metrics here. I will show in the next couple of slides. So what we have as the access 3.1.3x and what hardware and software is supported. And you will see feature on the left. So if we talk about management, so this is a DNA Center, and the recommended one is this 1.3.3.6 version. And then you can look to the identity. So ICE, the recommended one is version 1.6 with a patch 7, and so on. And when you scroll down, also for other devices, like for a Fabric Edge or the control plane node or for the border node, you will find the recommended switch software version. And yeah, for example, 9400 switches, 9500 switches. So what is the recommended hardware, as well what is the recommended software for this switch to run. Okay, some more resources you can find on cisco.com. They're pretty much self-explanatory. So SDA resources, there is also community. So I will not go through this. Very good let's say, documentation you will find on this solution. You may look into this CVD, so Cisco Validated Designs, where you will find a PDF, quite a long PDF, where a solution is described, all the components, and what is the best way to create this solution. There is a lab you can run in the dCloud. This is more related to the DNA Center, but I still included this in the presentation. And then there are a couple of Cisco Live lectures, quite a lot of them. But if you will go through any of those, please make sure you have a learning map from the Cisco Live. You know, Cisco Live is a platform where you can basically look for the sessions back because they are recorded, and you can look into those sessions. At least start with the first one when you will see some details, and every of these session takes, let's say, around 1.5 hours to 2 hours to listen. There's also a good way you can download this session and listen them offline if needed. Okay, with this we end my presentation, and let's look to your questions. I will quickly open my Q&A window, and pretty much I'm sure there are some questions here. Okay, what is FIAP? Okay, yeah, I didn't talk about this. FIAP refers to the fabric in a box. This is basically switch, Catalyst 9K switch, where you have all functionality available. So you can have switch with a control plane node, with a border node, with the edge node. So this is more relevant for the small offices because this solution with each of these components being a separate device, maybe for let's say mid-size to large offices, but for a smaller branch offices, this may be a good solution. So to purchase a single Catalyst 9K switch and then run all these things on such a switch. You may also have such switch with embedded WLC software running. So you have actually everything in one box. Another one, what are extended nodes in the fabric? Okay, when I talk about the solution where we have edge nodes, control node, border node, I didn't mention these extended nodes that you can basically connect to the end nodes. And these extended nodes are providing you a higher port density on the location. So with the extended nodes, these are basically switches that they not directly perform edge node functionality, but they provide you more port density on the location. So this may be also some of them. Okay, let's look a couple of more. Okay, another question is about a mixing environment with the SDA sites and non-SDA sites. Yes, we can do that. Such solutions are addressed with a common name, brownfield, where you have existing environment and you want to move step by step from the non-SD-Access to the SD-Access. You can have even the solution where part of your network is the SD-Access enabled, but the other is not. And they can work together, even if we talk about a wireless or a wireless partner. So they may exist together. Basically, we had a couple of examples where customers were building a completely new site, and they say, okay, we will go completely to the SD-Access to this site. So this was the completely greenfield approach for them. But then on the other side, the customers, they are not in the, let's say, purchasing cycle of the renewing of the hardware. They say, okay, let's just go step by step. So first thing is controller. So bring DNA Center up, and then slowly transition edge devices to the SD-Access enabled. Okay, another question, can we make a policy that says allow deny SGT to SGT, at the same time deny source IP outside the fabric? Yes, we can make such a policy, yes. Because SGT to SGT policies, so these are group-based access policies, are related to the fabric itself. But then when a fabric communicates to a non-fabric or to the non-SD access, then you need these IP-based policies. Okay, I will provide to this link to the sites that I had here. Let me see if this will work in the chat window. Very useful links I pasted in the chat window when you're starting developing SD-Access. Yes, you will get a recorded session URL later from us. Our production team will go through it, doing it pretty, and then you will get a URL for this recorded session. Question about a control node is a DNA Center? No, control node is just a Lisp server. So control node is inside the fabric to provide mapping for the endpoints. So this is a control node. DNA Center lives outside the fabric and is only controlling those devices. I just picked this from the session. Okay, guys, I see some questions are repeating, so let's wrap up. If any additional questions, this is my email address. You can also contact our team here at NIL, and we will definitely provide you some more information about the products we are providing. I also invite you to other webinars. We will deliver some webinars on other products. So have a look into this with future webinars we will run in next couple of months. Okay, by saying this, thank you for your participation, and we'll see you soon. Goodbye.